Hello everyone and welcome to this instructional video on interfacing keypad and LCD, which is part of lab 4. So in this instructional video, what we are going to see is how to interface LCD, which is a 16:2 LCD, and a keypad, which is a 4:3 keypad, to the microcontroller, and how to write programs to make both these peripherals work. So if you look at the aim of the lab, the aim is to learn how to interface advanced I/O peripherals, LCD and the keypad, create programs to display characters on LCD, and create programs to read inputs from the keypad. So first thing you have to do is create a schematic as shown in figure 1. So in this schematic, you have a PIC 16F877 microcontroller. MCLR pin is tied to high or VDD. A 16:2 LCD is interfaced using the connections as shown. And you also have a 4:3 keypad interfaced in this way. So the 4:3 keypad has 3 column pins and 4 row pins. The rows are connected using a pull down to a ground, and the reason for that is because each of these buttons on the keypad represents a push button switch. So I'll explain about that in a minute. Now let me switch over to Protus, where I have created this schematic. So as you can see, I have a 16:2 LCD. So we are going to use the LCD in a 4-bit mode, where we are only going to use pins D4 to D7. So pins D4 to D7 are the data pins, and they are connected to the microcontroller pins of port D. So pin D4 on the microcontroller is connected to D4 in the LCD, and likewise D5, D6, and D7. So these are the data pins of the LCD. LCD also has control pins, which are E, enable, RW, read write, and RS, which stands for register select. So E is connected to pin E0 on the microcontroller, RW is connected to pin E2, and RS is connected to pin E1. So you need to make the correct connections in this way. Also note that the LCD has a VSS and a VDD pin. So VSS is connected to VSS should be connected to ground. VDD is connected to 5 volts or high, and VEE is connected using a potentiometer. So this is the common pin of the potentiometer, where the other 2 terminals are connected to high and ground respectively. So basically this potentiometer is used to control the contrast of the LCD. So it won't make a difference in simulation, but if you are doing hardware work, you need to connect it in this way so that you can control the contrast of the LCD. Otherwise, you are not going to see anything displayed on the LCD. Now on the keypad side, the column pins are connected to B1, B2, and B3. So column 1 is connected to B1, column 2 is B2, and column 3 is connected to B3. The row pins A, B, C, D, the row pins are connected in this way. So row 1 is connected to B4, row 2 B5, row 3 B6, and row 4 B7. And also note that the row pins are connected using a pull down resistor to ground. And the reason why we use this pull down is because each of these keypad buttons acts as a push button switch. So it is like this. So let me switch over to my whiteboard so I can explain. So here it is. So if you look at the 4:3 keypad, each of the buttons in the 4:3 keypad is a push button switch, as you can see here. So the number 1 is represented by a push button switch, number 2 number 3, and so on. So all the numbers and the hash and the asterisk. So since these are push button switches, we have learned how to interface a push button switch where we can either use a pull down resistor or pull up resistor. So in this case, we are going to use a pull down resistor because the default state of the input, so the rows are the input and the columns are the output. So when you when you interface the keypad to the microcontroller, please note that the rows are the input and the columns are the output. So output of the microcontroller. So basically what happens is that, so one end of the push button is connected to the input. So since it's connected to the input, it needs to have a default input state. So if you connect this using a pull down resistor to ground, then by default it will have a state as 0. So the pins won't float. Now the other end will be connected to the output pin of the microcontroller. So the microcontroller can send either a high signal or a low signal. So when the microcontroller sends a high signal, this is activated. So when this push button is pressed, you will see a high input on, let's say, row 4. So basically, a keypad is nothing but an array of push button switches. Now how the keypad works. So to enable the keypad to work, we need to have a keypad driver. The keypad driver is a software program which controls the keypad. So what the keypad driver essentially does is it makes one of the column pins high. So let's say if it makes C1 high, and then it checks all the row pins. So it will check row 1, row 2, row 3, and row 4. So if any of, let's say when it makes C1 high and it, upon checking, it sees that R2 is high, this means that number 4 is pressed. Button number 4, button representing 4 is pressed. Okay. So, and then it keeps on doing that. So after making column 1 high, it goes and makes column 2 high. So when it makes column 2 high, it checks all the rows. If none of the rows are high, that means none of the second column buttons are pressed. Then it moves on to column 3 and then makes column 3 high and checks row 1 to row 4. So if none of the column 3 buttons are pressed, then it again goes back to column 1. So it keeps on doing this in a loop, makes each column high and then checks all the row pins unless and until one of the row pins becomes high. That means a key is pressed, as I have explained. If let's say column 2 is high and the microcontroller found that R1 is high, row 1, that means button number 2 has been pressed. So that's what the keypad driver program does. It waits in a loop by making columns high and then checking rows. As soon as any one of the rows are high, it returns the value of the key of the corresponding key. So let's say if it makes C3 high and row 3 was high upon checking, then it returns obviously pin number or 9, assuming that button representing 9 is pressed. So that's what a keypad driver does. Now, what I want to do is look at the program for the LCD and the keypad, and I'll switch over to the CCSC compiler where I have put the program. You can also see the program in the lab handout, so which is similar to this. So In this program, the first four or first three lines are standard, as we have seen previously. Hash include 16F877, hash fuses, HS no LVP, no watchdog timer, hash use delay, so we are using a clock of 20 megahertz. And then we have also included a standard library. So we are going to use some functions from this std library. And the rest of the hash defines, which is from line 6 to line 12. So this hash defines basically define which pins of the microcontroller you are connecting the LCD pins. So we have declared LCD enable pin is connected to pin E0. LCD RS pin is connected to pin E1. Now you can change this in your program, but then you have to make changes in the hardware as well. LCD RW pin is connected to pin E2. Data 4 is connected to pin D4. Data 5 is connected to pin D5, and so on. So basically you're defining where to which pins of the microcontroller you have connected your LCD pins. So this is what you're doing using this hash define statements from line 6 to line 12. Next, so after defining the LCD pins, then you need to include the LCD driver. So LCD driver is lcd.c file. So this is installed by default when you install the CCSC compiler. So you don't need to install it separately. And then there's another include file, which is keypad.c. So this is not installed by default. So what you have to do, you have to go to Moodle. There is a file on Moodle called keypad.c. You have to download that file, and then you have to place it in the same folder as you place lab4.c. So if you go to Moodle, you can see in Moodle on the software or code page at the bottom, you have two drivers given. So one is the keypad file and the other one is the DS1307 driver. So the keypad driver is the one which you have to download. So what you do is just do right click and save link as. Click on save link as and it will download this file. After downloading, you have to keep it in the same folder as the folder in which you have created your C program, your PIC-C program, which is this. So the folder where you have stored your lab4.c, which is here, this file, you have to place that keypad.c in the same folder. Then this will compile, otherwise this will not compile. Now looking at the other part of the program. So you have void main. So this is the entry point of the program. So this is where the program will start from. In void main, we have declared a char variable. Char is basically stands for one character, K. So char is just one character. Now the lcd.c file has several functions that you can use to display data on LCD. And basically there are only two main functions that you can use. One of them is lcd_init. So this function you have to call it at the start of your program. So before you write anything to the LCD, you have to call this function lcd_init. So this will basically initialize the LCD. The next function is lcd_putc. So this function basically displays a string on the LCD. So string is an array of characters. So in this case, what I'm going to display is ready and then 3 dots after space. So if you look at these statements that start with backslash, so \f and \n. So these characters have special meaning in C programming, which you might already know. So for example, \f means clear the screen. So it's going to clear the LCD screen and then put the characters ready on the first line of the LCD. \n means move to the next line. So it is going to go to the next line. So you might have already encountered \n in C++ programming. Now there is a while true statement, which means this loop is going to repeat forever as long as power is supplied. There's a statement delay, so there's a 2 millisecond delay, and then there's a function called read keypad. So this function is going to, so this is part of the keypad driver, keypad.c. This function is from this driver. So what this function does is, as I have explained, it makes one of the columns high, checks all the 4 rows to see if they are high. If not, it moves to the next column, column 2, checks if the rows are high. If not, it moves to column 3, checks if the rows are high. If not, it moves back to column 1 and keeps on doing this in a loop. So basically, if you call this function read keypad, it will be stuck in a loop. So this program will be stuck here unless and until you press a key on the keypad. So as soon as you press a key on the keypad, it will retain the character equivalent of that key in the variable k, because k is a character. So it will retain the character equivalent of the key that you press. So if you press a number, let's say from 0 to 9, that number will be a character. It will be represented as a character. And then it says if k is not equal to 0, that is if k is not null, then within this if there is another if else. So if k is equal to star, that means you have pressed the star, then it is going to clear the LCD, because \f clears the LCD screen. Otherwise, it is going to put that character or display that character on the LCD screen. So basically, this program is going to display the characters that you are going to press using your keypad on the LCD screen. And if you press the character star, it will clear the screen. So let's see how this program works. Note that you need to have the keypad.c file in the same folder where you put lab4.c. So if you build this program, it is going to build successfully without any errors if you have the keypad.c in the same folder as your lab4.c. Now let's go over to my Proteus screen. So now in Proteus, I have created the schematic properly. I have interfaced all the components. Now to simulate this circuit, what we can do is right click on the PIC16F877, go to edit properties. You can change the processor clock frequency to 20 megahertz as I have done here. And then you need to check the program file, which is lab4.hex. So if you try to browse for the program file, lab4.hex, so it is in the folder lab4, which I have saved on my computer. So you can see that there are two program files. There's a debug file as well as a hex file. I prefer using a hex file. So use lab4.hex, the one which has the icon which shows a bunch of zeros and ones. So just select that and click open. So now that program is linked to this PIC16F877 microcontroller. And when we run the simulation, it is going to run the program that is in lab4.hex. So that is after we compile using the PIC-C compiler. Now I click on OK. Now I can run the program. So if I click on simulate, so it's starting the simulation, and as you can see, the LCD displays ready, space and 3 dots. So that is what we have written in our program. Now, if we press any key, it should display the number of that key on the LCD. So if I press 1, can you see it displays 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, hash. It even displays hash. Now if I press star, and as you have seen in the program, whenever we press star, it is supposed to clear the screen. So when I press star, it clears the screen. So now nothing is being displayed on the screen. But now I can, again, whatever I press will be displayed on the LCD screen. So I can press a bunch of numbers, and whenever I press star, it gets cleared. Can you see? So I can press any number, and when I press star, everything gets cleared. So that is exactly what we have written in our program. So again, reiterating on what the keypad driver does, let's see in my notes. The keypad driver makes one column high, okay? Makes one column high and then checks if any row pins are high, right? If any row pins are high, then it returns the value corresponding, the value of the button corresponding to that pin, to that column pin. So for example, if C1 was high, column 1 was high, and if R2 became high, then obviously button 4 must have been pressed. So it will return 4. The keypad driver is going to return 4 as a character. So it returns the value of the row pin that is high. Next, it keeps on repeating until a key is pressed. So as soon as a key is pressed, the function read keypad will return. So it does all these things. So let's go back to my notes. So the source code is there in the notes, exactly what I have explained. Now, if you look at the notes part, it says, please refer to the WH162B character 16 by 2 LCD data sheet online for more information on pin descriptions of the LCD. So you can search for the LCD data sheet, which is this, for more information on LCD pins. Please note that in this lab, the LCD is being treated as an output device. You will not go much deep into LCDs, but you'll only learn how to program it as an output device to display characters. So we are not going to see how actually LCD generates characters and all those things, but we'll have a broad look at it in terms of how to display characters. Pins 4, 5, 6 of the LCD is the LCD control pins, and pins 7 to 14 are the 8-bit data pins of the LCD. The LCD will be used in 4-bit mode, thus only 11 to 14 will be interfaced to the PIC, as I have shown you. To drive the LCD driver program is needed. So this is the LCD.C program that we have looked at. Next, two important functions to take note in the program is LCD underscore initialize, which I have already explained, and LCD underscore put C, which displays the characters on the LCD. These functions are part of the LCD driver program, and it makes our work easy in displaying characters. So LCD driver, which is LCD.C, is provided when the C compiler is installed. Okay, so next, to make the keypad functional, a keypad driver will be used. The keypad driver, keypad.c, contains a function called read keypad, which reads the keypad input. Please note that keypad.c files should be in the same folder as the Protus project. or in your C file, C source file. C source file folder. So whenever you create the program that is in this lab, wherever you store it, you store the keypad.c after you download it from Moodle in that same folder. And then lastly, let's look at the exercise part. So it says combine the keypad and LCD programming concepts and create a password program whereby the LCD displays to the user to enter a password. The user should be able to enter the password from the keypad. If the password is correct, the LCD should display welcome. If the password is incorrect, the LCD should display wrong password and give the user 3 chances. If the user is not able to enter correct password in 3 chances, the LCD should display end of program. So you can work on this exercise. You can think about, so basically this exercise consists of you being able to use your programming knowledge in C and C++ to be able to do this. You already know how to read characters from the keypad. You know how to display characters on the LCD. And then you can just integrate the other parts like getting the password from the keypad. You can have, let's say, a 4-digit password um, consisting of any characters, hash, 0, star, or asterisk, and so on. And so basically, this is just a programming exercise. No more hardware changes need to be made or schematic changes needs to be made for this exercise. Also note that this exercise is also beneficial for those groups who are doing projects on door lock system, whereby you have a keypad and an LCD. So to unlock the door, you need to provide a combination of keys or password. And then once you provide the right password, then the door is unlocked. So those who are doing that project, this exercise will be useful to you. If you are able to do this successfully, then you will also be able to work or do your lab successfully. So I'll provide at the end of the course, I'll provide the answers to these exercises. In fact, to all the exercises in the lab handouts. So with that, thank you. That's the end of this video.